Hello students. So today we are going to start or do in this video a very small part of the chapter atomic structure, but this is considered as the most important part of this chapter. So what is it? It is basically how the electrons are distributed in the various shells. So let's start with it. See, you have learned that there are various atomic shells. The shell which is closest to the nucleus, if the red portion is considered as the nucleus, then the shell which is closest to the nucleus is known as the K shell. The shell which is after K shell is known as L, and then M and other shells which are after M, N, O, like that. We designate the shells with these letters. So, the shell which is closest to the nucleus, that is the K shell. Okay, the next shell is the L shell. Next is M shell. So, the topic is that how the electrons are distributed in these shells. So, we will do that. We will definitely come to that part. But before starting with that part, let's know about Bohr-Bury scheme. Now, what is Bohr-Bury scheme? Bohr-Bury scheme says that the electrons in each shell, the number of electrons in each shell is equal to 2n square. Now what do you mean by 2n square? I'll come to that definitely. For K shell, which is the first shell that is closest to the nucleus, the value of n becomes 1. For L shell, that is the next shell, the value of n becomes 2. For next shell, which is the M shell, the value of n becomes 3. For N shell, it will become 4, like that. So, the number of electrons which can be accommodated in the K shell. Let's see, the formula is 2n square. So, K shell will have how many electrons? 2 into n square. What is the value of n? That is 1. So, 1 square means 1 into 1. So, which will give you 2. So, the maximum electrons that can be accommodated in the K shell is 2. Maximum electrons. Remember, maximum electrons. Next comes the L shell. See, the value for n is 2 for L shell. So, 2 into 2 square. With 2 square means 2 2s are 4. 4 into 2, that will give you 8. Okay, so basically the maximum number of electrons that can be filled in the L shell is 8. Remember again, maximum number of electrons. Next comes the M shell. The value of n is 3 here. So, 2 into 3 square, and that is giving you total of 18. Now there is a concept. We generally say that M shell can hold a maximum of 18 electrons. Okay, we can consider that. But that is according to the Bohr-Bury scheme, we can consider that the M shell can hold a maximum of 18 electrons. But actually what happens, the M shell, if there are 18 electrons in the M shell, we know one thing, right? We know that the like charges will repel each other. There will be an inter-electronic repulsion if the electrons are very close to each other. So, we know the electrons are negatively charged. So, the negative charges of the electrons will, what will it do? Will repel each other. So M shell is not very big in size. The size of the M shell is not very large. So if there are 18 electrons in the M shell, then there will be a strong inter-electronic repulsion. As a result, the maximum electrons that can be accommodated in the M shell becomes not 18 but 8. Okay, so by knowing the Bohr-Bury scheme, let's start with one of the elements. See, I have taken here sodium. I'll show you the filling of electrons for sodium. Sodium has an atomic number of 11. So, atomic number 11 means sodium will have 11 protons. As an atom is electrically neutral, so if it have 11 protons, then it will also have 11 electrons. So, 11 electrons. I have told you the K shell can hold a maximum of 2 electrons. So, I am putting 2 electrons in the K shell. See, after I have put 2 electrons in the K shell, we are left with 11 minus 2, 9 electrons. Okay, I have told you the L shell can hold a maximum of 8 electrons. So let's put the 8 electrons in the L shell. 1, 2, 3, 4, 5, 6, 7 and 8. Now we are left with how many electrons? 11 minus 2 minus 8, that will give you 1. So, I have told you that in the M shell we can hold a maximum of 8 electrons. So, only 1 electron is left for sodium. So, we will keep that 1 electron in the M shell. So, we can see that this is the atomic model for sodium. Sodium is having 2 electrons in the K shell, 8 electrons in the L shell, 1 electron in the M shell. Now, if we want to write the electronic configuration, how we will write? Yes. So, let's start with the electronic configuration of sodium. Okay. Electronic configuration. The first shell is holding how many electrons? 2 electrons. So, for K shell 2. We will give a comma after that. How many electrons are present in the L shell? 8. So, 8. And the last shell, that is the M shell, is having how many electrons? 1. So, the electronic configuration of sodium is 281. Okay, students, so this is how we generally feel the electrons in the shells, the K shell, L shell, M shell, N shell, and this will continue as the size of the atom increases. Okay, so this was a short video on how the electrons are filled in the various shells of an atom. This example was given for sodium. Now, in the later videos or in the videos after this, we will continue with various other atoms. We will continue like how in various other atoms the electrons are filled. So, thank you, students. Thanks for watching. Thank you.